Hello and welcome to 9 to 5 Data, where we talk about data analytics. In this video, I'll be showing us how to build a portfolio project to showcase our SQL skills to potential employer. And in this video, we'll be working as a data analyst for an hypothetical company called PizzaPalace. In the real world, the way it works is that as a data analyst, you work hand in hand with business stakeholders and business executives, and with them, you try to answer business problems. So, as a data analyst for PizzaPalace, we have a list of business problems that is executive or the business stakeholders of PizzaPalace have put together, and they want us to use their data to answer this. So, as we know that data is everywhere, but it becomes useful when stakeholders can make or take decision from the data. So that is why in this project, we are going to help PizzaPalace use their data to answer problems they have been facing in their business. To do that, you as a data analyst, you've had a meeting with PizzaPalace, and in the meeting, the business problem that's discussed are these ones that I'm showing to you now. We have problems like, what is the total number of orders received? The next thing is that they want to know the total revenue generated, which pizza types are our highest and lowest priced pizza, and how much do they cost. The next question is top 5 most ordered pizza types along with their names and quantities. What does pizza orders look like by hour of the day? What is the average number of pizza ordered quantity received per day? What is the contribution of each pizza category to the total revenue? What is the top 3 pizza types based on revenue for each pizza category? Which postcode area generated the highest pizza order? So in the real world, this is what usually happens. There's a lot of business questions that we need to use data to answer. And right now, before you start answering the question, as an upcoming analyst or an aspiring data analyst, having these business questions most of the time is really overwhelming for a lot of people. And what I've done is that I have an approach that I use, a kind of workflow that I use, and this is also what I use in real life to help me streamline how to connect the business questions to the data sets that I have in hand. So if we go to the approach now, so the workflow is that there are 3 sub-steps to follow, and the first one is understand the business question. So before you start to do anything, it is important that you have an understanding of the question that you are being asked. A good understanding of the business question is what will help us answer these questions and ensure that they provide the insight that the stakeholders are looking for. So after we understand this business question, which usually happen by having series of meetings, and then the stakeholders coming up with the questions they would like us to answer for them. So the next thing is to get the data. So in the real world, data lives in the database, but for the purpose of this tutorial, for the purpose of this analysis, we'll be loading the data from series of CSV files, which the download link will be available in the description. If you check the description of this video, then you get the download link. So once we have that, the next thing for us to do is to load the data. After loading the data into the database, the next thing for us is to understand the data in the database. So in the real world, definitely we have to maybe skip the step 3 of loading the data into the database, which we know that the data is already going to be there in the database. So the most important thing for us now is to understand the data in the database, which definitely that is what we are going to use in answering our question. And after that, once we have access to the database and we can do an exploration of the database, the next thing is to clean the data, which is an important aspect of data analysis. We work with clean data. That is how we are going to be sure that we are providing the right answer or the right insight into the business questions being asked. So after cleaning the data, we have to save the clean data as a view so that we can start using that as a base to answer the question. So once we have a clean data set and we have saved that as a view, the next thing is to then answer the business questions we have at hand. So once we've answered all the business questions, we then save the SQL code and add it to our portfolio. Now we are going to start looking at these steps one after the other. So this first step, which is understanding the business question, that one we've already done that. And also it is a continuous process, because once you start to go into the database and try to look at the database and answer the question, so you still have to understand the questions and be able to interpret them. So it is a continuous process, and it's not just a one-off task to be done. So now we move to the second step, which is getting the data. The data we'll be using a series of CSV files, which definitely you should have access to. And to get the data, I said it will be in the description below. And now we need to load that into our database. So to do that, let's go to our SQL server and let's open SQL server. So this is my SQL server and I'm connected to my server. So the next thing is that we need to create a database that is going to hold our table. So to do that, let's right click on our database and click on new database. So once you click on new database, it's going to ask you to supply the database name. So for the purpose of this video, we are working for an hypothetical company called the PizzaPalace. So that is the name we are going to name the database. So we say PizzaPalace DB and just click on OK. And once we click on OK, just refresh your database again to get the PizzaPalace DB. And if you scroll down a bit, you then see this is now part of our database. So the next thing is that we need to get data sets into this database. So to do that, you right click on the database and click on task. And then there are different options to pick from here when you are trying to get data into the database. So for the purpose of this video, we are going to only demonstrate one part, because the files that contains our data are CSV files, and CSV files are also known as flat file. So we are going to then click on import flat file. So there are other options like import data, export data. So because we are bringing data into this place, so we just select import flat file. And then we'll be greeted by this dialog box. So the next thing is just click on next. And once you click on next, you have to browse to the location where your files are. So I'm doing that now. So I have the data set. So for this video, we are working with 4 CSV files. We have the pizza type, which contains the pizza informations like the pizza type, ID, the name, the catalog and ingredient. And also we have the order, which contains the customer order, and we have the order details, which is the transaction details, and we have the pizza table, which contains the variant of pizzas that we sell. So let's start importing them one after the other. So the first one is, I'm just going to import them as is shown on this folder. So let me click on order details and click on open. So click on next. And you're going to get a preview of the data we are trying to bring in. So this data has 4 columns, and right now it looks okay, and I don't think anything is missing. So click on next. And then this is where we have to then modify the column, like changing the column name, the data type, and if it is a primary key, and if we want to allow no. So most of the time when I'm importing data into database, I try to understand what the column names are, the data types, and if I'm trying to select anyone as the primary key, or if I want any of them to allow no. So I'll start with allow no's. Allow no's is trying to tell us that a particular column can contain null values. But because we are importing data into SQL Server, so most of the time I might tick everything and sometimes I just leave them blank. But for the purpose of this video, I believe the quantity can be null. So I'll just leave the order ID and pizza ID and the order details. That should not allow null, because I feel it is really important for us to have those information before a transaction can occur. So the next thing is the primary key. So for this table, we are bringing in the orders details table, which contains the transaction. So, and every table must have a primary key, and it is important that we select that. So let's click on this other details ID as the primary key. And now for the data type, I don't usually touch them. I just leave them the way it is, especially if it is coming from CSV, because sometimes the CSV usually have encoded into it the data type. So most of the time I just leave it the way it is. And if we encounter an error, we might come back to fix that. So let's just leave this and click on next. And now it's going to give us a summary of everything we've been doing so far. We are trying to import data into the database name, which is the PizzaPalace DB. The name of the table is going to be other details. And the file to be imported is this CSV file, as you can see the name. So let me just click on finish and for it to start loading. So now we encounter an error. So the next thing for me to do is to actually click on this error to understand why am I getting this error. So click on error and it's going to give you the error information. So as a data analyst, it is important that you don't panic when you have an error. Just take your time to understand it. And if you don't understand the error, you can copy it and Google search it. Definitely you see something on the internet or give it to AI. So definitely you see something on the internet that's going to tell you what that error means. So now let me look at it. So it says error inserting data into table. Okay. And additional information after saying that, it says the given value 256 of type string for the data source cannot be converted to type int for column 1, which is the order ID. And it failed to convert that parameter value from a string to a byte. So value was either too large or too small for an unsigned byte. So right now, from the old information, what I'm getting is that the data type for order ID is wrong and it has to be changed. So let me click OK and then go back to previous. And then if I look at order ID, it is saying the data type is tiny int, which that is too small. And what we have to do now is that we can actually change this from tiny int and just give it integer. And I'll do the same thing for everything that has to do with int and just give it this integer. And do the same thing for quantity so that I'm going to save myself from any error in the future. So now I've changed everything into integer and then click on next and finish. And right now we get the result that this is successful. So what I'm going to do now is just close this and repeat the process again and bring in the remaining data set. So let's do that now. So I'm just going to change this to primary key and then I think all these are fine. So let me change this to int. And I think the rest of them are fine. So click on this, finish. And that is successful. Do for the other one, task. And then import flat file. So I'm doing for pizza type. So make this the primary key and then leave the rest like that. So click on next and finish. And then task again, import flat file. Next, this pizza. Next, and then next. Make this the primary key. So I think the data types, everything are fine. So I'm clicking next, finish, and close. Now I've been able to bring in the 4 CSV file that we'll be using. We've imported all of them into our database. So to see this now, the first thing we need to do is to refresh this database. And once we refresh that, we need to expand this and expand table. And once we expand table, then we can now see all the tables in the database, which is the order details, orders, pizza types, and pizzas. So this is the third step of loading the data. Now we have the data in the database. So the next step is understanding the data in the database. So we need to understand the data before we start to answer questions. And to understand the data, what this means is to understand the columns that are in our tables. What do they mean, and what kind of data types they are, and what are the sort of things we can do with them, and also how are these data sets connected to each other. So we need to understand that. So the first thing to do to understand the data is to right click on this and select top 1000 order. And if you do this, you can see a preview of the data. We see that the order details table contains order details ID, order ID, pizza ID, and quantity. So the next one is to select the top 10,000 of order. We have the order ID, the date and time, and we move to the pizza type. We do the same thing. And in the pizza type table, we have the pizza type ID, we have the name, and we have the category and ingredient. So let's do the same for pizza. So we have for pizza, we have pizza ID, we have the pizza type ID, and we have the size, and we have the price. So definitely, once we have all these, we still need to understand how these tables are connected, because this doesn't give us an understanding or an explanation of how these tables are connected. To find out how these tables are connected is that underneath our database, we have something we call database diagram. So it's not usually available for every database you are going to work with, even though in the real world, sometimes they have it, they don't have it. But it's just for me to give you an explanation, because in the real world, to have a better understanding of this data, we have something called data dictionary, which definitely will be provided for you. So in an ideal situation, there will be a data dictionary which will tell us every columns in our table and every values in our database, what it means and what they are recording. So let's go to the database diagram. So once you go to the database diagram, so we are going to create a new database diagram. Click on new database diagram. And this information is telling us that this database does not have one or more of the support objects required to use database diagram. So do you wish to create them? So we'll just say yes, we want to create our own. And then this will give us the list of tables in our database. So we select everything and then click on add. So we have a new window where all the tables will be added together, and let's close this. So we can now see the tables, the 4 tables that we have in our database. We can now see them and the column they contain. So what I'm trying to now do in this place is that I want to link each of these tables together to see how these tables connect or talk to each other. So what we are working with is called related database, RDBMS, related database management system. So now if you look at the pizza type, you see that we have pizza ID, which is the primary key as the key icon beside the suggested. And the next thing is that it has name, category, and ingredient. So what we are trying to look for in each of the tables is to look for primary key and foreign key. So for now, we can only see pizza type ID as the primary key in this table because that is the only column with the ID in front of it. So if we look at other tables and we see that it has more than one ID, then the first thing we need to do is to identify which one is the primary key, and that is usually indicated by the key icon beside it. And then we believe that the rest of the IDs would then be foreign keys, which are primary key in another table. So what we're going to do now is that bring this orders details table down, and then we have the order details ID, which is the primary key. Then we have the ID, the order ID, and we have the pizza ID. So definitely this table, this orders details table can connect to the orders table and then can connect to the pizza table. So let's bring it this way and this way. So what we're going to do now is that we are going to drag the primary key from the orders table to the order details. So let's drag the ID to the ID on this place and drag it to the order ID. So you get this dialog box because we imported data. So if, for example, we use SQL code to create the columns, we would have created all these from the beginning, but because we imported the data using CSV file, so that is why it's asking us this information, and it's going to now create a foreign key for us. It's going to create a relationship which is known as the foreign key. So now all we just need to do is to click OK and then click OK, and that is done. So we do the same thing for pizza ID and we drag to the pizza ID. So just click OK and OK. So now we have all these. The next thing is that if we look at the orders table, we only have orders ID. So there's no any foreign key here. And if you look at the pizzas table, we have the pizza ID and we have the pizza type ID, which definitely this is a foreign key and it's going to be primary key in the pizza types table. So we can drag the pizza type table to this side, and then this is the primary key. Drag it and connect it to the foreign key here, and it's going to say OK and OK. So the reason why we have done this now is to understand how these tables are related to each other. By understanding these, we now help us to know how do we answer questions, how do we clean the data, and how to work efficiently with the data. So what I mean by working efficiently with the data, answering questions, sometimes when you need to answer questions, you need to join 2 or 3 tables together. So by understanding the relationship between these tables, how these tables are connected, you would understand which tables can be joined together to actually produce the answer you're looking for. So now we are done with understanding the database. The next thing is cleaning the data. So when we look at the data in our table, it looks clean for now. For me, there's nothing to clean. The formats are okay. The numbers are fine. And I don't think there's anything to clean. So in most cases, like I said before, sometimes you will find yourself working with very dirty data, which you need to do some cleaning. And if you watch some of my previous videos, you will see how I have demonstrated how to clean data. So, and in some cases, you find yourself with very clean data sets, which you don't need to do any cleaning, or the cleaning you have to do will be very minimal. So now, since we don't need to do any cleaning, so we are going to skip this step 5, and then we are also going to skip the step 6, which is saving the clean data as a view. So we don't need to save anything as a view because we are not cleaning anything. So we are just going to write our query against the data set, against the database itself, without saving anything as a view. So now we are skipping step 5 and we are skipping step 6. So what we need to do now is to move to step 7, which is to start answering the business question itself, and we're going to do that one after the other. So now let's click on new query. This is on the new page where we have to answer the question one after the other. So the first question is total number of orders received. So total number of orders received. So to look at this now, we need to understand which table is going to help us answer this question, as it says total number of orders received. So what we are going to do is that we are going to inspect our diagram again, and you see now that if you look at this diagram, we have the orders table and we have the order details table. So the difference between the orders table and the order details table is that the orders table is where we get the information on the order ID, the date the order was placed, and the time. So the order details is giving us the overall transaction, the details of the overall transaction, which is the order ID details, the order ID, the pizza ID, and the quantity. So it's giving us the details of the transaction. To answer our question now, we are sure that it is the orders table that is going to help us to answer this question. So we go back to our query and say, let's select everything from orders. And once we do that, let's run this. So we have this. So the best thing for us is just to count the order ID column. So we are changing this to count. And call this total orders. And then let's run this. Now this is our total orders. We have 21,350 orders received. So that is really straightforward and nothing difficult at all. So we move to the next question. And the next question is total revenue generated. So the next question is total revenue generated. So let's go back to our diagram to understand how to do this. So when we look at our diagram, we see that to get revenue, we have to understand if revenue is being recorded directly in any of the table. So when we look at any of the table, we don't really have revenue recorded directly. So if we look at the other details, which I believe should give us the detailed transaction that has happened, it only has the order details ID, order ID, pizza ID, and quantity. And when we look at the pizza table, we see that we have the pizza ID, pizza type ID, size, and price. And when we look at this, we discover that we have quantity in a different table, we have price in a different table. So the definition of revenue is the money generated, that is the price multiplied by the quantity sold. So once we know that the formula is the price multiplied by the quantity sold, then we need to bring the tables together, the two tables together, to be able to write this expression out. So now what we are going to do is select from order details table and join. So it's going to be an inner join. So is either you put join or inner join, is still going to give us the same thing. So we are joining this with the forgotten. Let me go back. We are joining it with the pizzas table. So we'll say pizzas. And now we are joining them based on, if you look at these, what is the common column between them, the primary key and the foreign key. So the primary key for pizza table is the pizza ID, and that is the foreign key in the order details table. So we go back to this place and I can name this P, give it an alias of P, and then give this an alias of OD. And now we are joining them based on the pizza's ID. So we're going to say od.pizza ID equals p.pizza ID. And now what do we need? We need to select the price. So we're going to be selecting the price from the pizzas, which is going to be p.price multiplied by the quantity, which that is going to be coming from the orders details, od.quantity, and then we say revenue. So let's run this first and see what we have. Once we run this, we can see that we are getting the row by row revenue generated. So what we are going to do now is to sum everything together, because what we are looking for is the total revenue generated. So we just put sum on this, and then let's send again. And now we have this, which definitely is having a longer decimal point. So when we're talking about money, you have to understand the currency you are dealing with. So for this video, I am making this video from the UK. So I'm going to, go with the UK currency and assume this is in pounds. So if we are dealing with currency, the best thing is to maybe round it up to two decimal places, which definitely will make sense instead of having this longer tail decimal. So what we can do is then round these to 2 decimal place. So we add round and then say 2 decimal place 2, and once we run this, so we have £817,860 as our total revenue generated. So I can name this total revenue to make it more clearer. Total revenue. So we have our total revenue. So that is for question number 2. So we move to the third question. So which pizza types are our highest and lowest priced pizza, and how much do they cost? So this question is very important for us to understand. So it is actually asking us 2 things, and it's not going to be something we can answer with one single query, one single SQL query. So first we need to understand what they are asking us. They are asking us the pizza type that is the highest priced pizza and how much do they cost. And same thing is to look for the lowest priced pizza and how much does that cost. So we are going to answer the first one, which is the highest priced pizza. So let's do that. Say this is going to be 3A. And what we're going to do is to look at how to answer this question. If we go to our diagram, again, you see that we have pizza type, we have the price, and we believe this table can actually answer the question for us, which is the pizzas table, because right now we have the price and we can get the pizza type from here. So the first thing is to get the highest price, and to get the highest price, we're just going to do select from the pizzas table. We are going to select the maximum price, and that should give us the highest price. So we believe the maximum price is this, which is 35.95. And now we are now going to look for which pizza type. So we can do this and say get PT pizza type ID. And then group by that. So we can call this highest priced. So let's run this. And now, if we look at this now, what it's trying to do is trying to group. So we have different pizza type ID that are belonging to different group. So definitely, this is not giving us exactly what we want. So what this is giving us is that when we look at the pizza type of BBQ chicken, we have 20.75 as the highest priced. When we look at the big meat, we have 20.5 as the highest priced. So for us to understand this better, I need you to pay attention to the number of rows these have returned. This returned 32 rows. And let's inspect the pizza type table. Select from pizza type. And let's see what we have. So if you look at pizza type table, we have 32 rows. So definitely what is happening in pizza type table is that if you look at this pizza type ID, look at the name, look at the category, and look at the ingredient. So this is BBQ chicken. This is BBQ chicken. This is the name, and this is the ingredient. So right now we have 32 types of pizza in our company, the PizzaPalace. They sell 32 types of pizza. And definitely when we now inspect the pizza table, so let me run the two together. So once we are inspecting the pizza type table is the one at the top and the pizza table is the one below. So when we look at the pizza type ID, we see that we have pizza type ID of BBQ chicken, which is the barbecue chicken pizza. And now on our pizza table, this is broken down into large, medium, and small. We can see that we have sizes of large, medium, and small. So definitely writing this query to see what is our maximum price, or which is the highest priced pizza, is going to then look at them at each category and look at the category of BBQ chicken and give us the highest priced in that BBQ chicken. Look at the category of big meat and give us the highest priced in big meat. Look at the category of Calabrese, which is another type of pizza, and give us the highest at that category, which is not what we are looking for. What we are looking for is to actually know which pizza in particular is the highest priced. And to get this now, so what we're going to do now is that we are going to get the pizza type ID and the prices of the pizza, and then filter or extract which of this pizza type ID is equals to the maximum price. So let me explain what I'm trying to do for you now. So let's do this and select price. So let's run this. So now we have all this pizza now. So what we now want to do is that we just want to extract out of this pizza which one is equivalent to the maximum price that we saw earlier. And to do that now, we just need to filter this to get us the maximum price. And what we're going to do now is that we're going to say where price is equals to, remember the formula we created to get the maximum price. So we are going to write a subquery and say where we are going to select max price from pizzas. So let's run this. So this is what we're trying to achieve now. We see that the Greek type of pizza is the pizza with the maximum price. It is the highest priced pizza. So we can now call this highest priced pizza. So we don't need this group by, we take the group by away. What about if we actually want to get the name of this pizza instead of just the ID? So what we're going to do now is that we need to join this with the pizza types table. So we are going to say this alias as P and then join pizza types as PT on P dot pizza type ID equals to PT dot pizza type ID. And what we need, so this one now we're going to make sure this is PT, or you can put it as P. It doesn't change anything because we are using an inner join. So the next thing we need again is that we need a name of that pizza type. So it's going to be pt.name, and then this we just add the alias of that pizza table to it. And once we run all these, let's see what we have. Now you can see what we have now, that the Greek pizza is the highest priced pizza. What if we want to get the lowest priced pizza? How are we going to achieve that? It's still straightforward. What we're going to do is just change the max to min. So let's delete all these and just copy this down. And this will be 3B, which is going to be, this is highest priced. And this is lowest priced. And the next thing we're going to do is just change this to min, which is the minimum, and then call this lowest priced. So let's run this. And we can see pepperoni type is the lowest priced pizza. So that is what we've been able to achieve to actually get the highest price pizza and the lowest price pizza. And looking at the question, this might look like a single question, but we have to break them down to be able to answer them separately, because there are two separate questions joined together as one. So now we have our highest price pizza and we have our lowest priced pizza. So let's move on to the next question. So question number 4 is, this is top 5 most ordered pizza types along with their name and quantities. So to answer these questions, what we have been asked is the top 5 most ordered pizza types along with their name and quantities. So definitely, if we go back to this diagram, we can count the order ID, but right now we don't have anything that is telling us about pizza type ID or the quantity they've ordered. So definitely we can't use this because it's not having all the information we need, and there's no foreign key that we can use to link to a different table. So if we look at the other details, this is going to answer our question because we have the order ID and we have the quantity. So now let's start building the SQL query to answer the question. So go back to this and say the most ordered pizza types along with their names and quantity. So select all from orders details. So we have these. So we have the pizza ID. Let's pick that pizza ID followed by counting the order ID, count order ID, and then they said the quantity. So instead of just, we can't count quantity because it's not a value to be counted, it's a value to be summed. Because when we talk about quantity, some people might order one quantity of pizza of a particular pizza types, and some people might order like 2 or 3 quantities of another pizza type. So for this now, what we're going to do is to then do summation of this and say sum the quantity and call it quantity. So this one, we say total order, and let's run this and see what we have. So I need to group by, and don't know why I forgot that. Pizza ID. So let's run this again. So we can see this now, and right now what we need to get is the topmost ordered pizza type. So but what we are using is the pizza ID, which definitely is not giving us what we want. So definitely we have to find a way to join this table to the pizza type to be able to get the pizza type and the name, because right now we only have the order, the count of the order, and the quantity. So let's look at our diagram again. So in our diagram, we definitely can join this pizzas table and the pizza types table to the orders details to be able to get the pizza type and the name. So let's do that now. So we are going to call this one OD, and we are going to join it with the pizzas table and call that P, and that is going to be on od.pizza_id equals p.pizza_id. So what I actually need is to get this pizza type ID and the name. So now that I've joined this, then the next thing is for me to join these pizza types with the pizzas table. So what I'm going to do now is then say join pizza type and call this pt on p.pizza type id equals pt.pizza type id. So now I'm going to delete this ID, pizza ID, because that is not what I needed initially. So what I needed initially was to get the pizza type ID, which is going to be pt.pizza type ID. And then I need to get the name. So it's going to also be pt.name. And once I have that, I'm going to be grouping by these two values and replace this. So let's run this. So now we have the pizza type ID and the name. So what we are going to do now, we need to get the one that is most ordered. The one that is most ordered. So we need to pay attention to that word. It is different from the quantities, the most quantities. So it is telling us we need to get the top 5 most ordered. So right now we are going to sort this value by the total order, which is total order. And then what we need to do is to get it in descending order. And then we need the top 5 most. So we're just going to do top 5 at this point. And then now let's run this. So now we can see that we have the top 5 most ordered pizza, which are the classic deluxe pizza, the barbecue chicken pizza, the Hawaiian pizza, the pepperoni pizza, and the Thai chicken pizza. Those are the top 5 most ordered pizza. So next is to go to the next question. The next question is what pizza orders look like by hour of the day. So this question is actually about answering questions around time series. So trying to see how the orders or the sales are performing by the hours. So to answer that, let's check our diagram again. We can see that we have order ID, date, and time. And we can actually answer these using this table alone because it doesn't require us joining any other thing. And this question is that straightforward. So now what we are going to do is to count the orders that we are receiving by the hour of the day. So that means we are going to be working on the time. So let's do select everything from orders table. And let me run this to see what we have. So we have this time. And if you look at the time, they are not particularly in the format that we want them. So you can see that we have some order. Let's look at the first 2 orders. We have one in 2015 01 11:38, and we have another one 11:57. So what we actually want to see is that if you look at this hour now, which is the 11th hour, so you can see that we actually received 2 orders. So that is the kind of information we want to see, not this breakdown by the entire time. So it's just by the hour. So the next thing is that we are going to then extract the hour part of our time. So to do that, we use a function called date part, and then the part we want to extract is the hour, and then we are going to supply it our time value, which is time, and we are going to call these hours, And now we want to count the orders that we are receiving by the hours. So we are counting the order ID and we are calling these total order received. And now, since we have this, what we are going to do is then group by these. So let's run this to see what we have. So now you see what we have. We have the hours and we have the total orders that we received for these hours. So when you look at this, it's not really intuitive. It's not really giving us any insight when we look at this result because the hours are not in chronological order. So what I would like us to produce is to see it from the minimum hour to the maximum hour. So definitely we can see our operational time and we can have a trend of when or the period when the orders are peaked and the period when the orders are depleted. So right now, since we have this, we just need to find a way to order the hours in ascending order. So what we're going to do now is then do order by the first part. So we can either say just one. So it doesn't really change anything. You can give the full name or you can just say order by the first column. So let's run this and see what we have. And now looking at this, you can see that we have our hour starting from the minimum hour to the maximum hour. So we can see our opening time, which is 9 a.m. and see our closing time, which is at the middle of the night. And looking at this, at the opening time, we received one order, so which definitely is intuitive. It's early in the morning. So I don't know who is ordering pizza at that time. So the next one, we have it 10 a.m. and after that, 11 a.m., the order starts climbing and we can see the immediate jump. And when you look at that, it kept on climbing again until we get to like 2 p.m., which is 14, and the order reduces again from 2 p.m. to around 4 p.m. So this can actually be explained as maybe saying people are starting to go to break like around 12 p.m. or people are just coming out of their homes to meet with friends around 12 to 1 p.m. So, but the most logical analysis I have for this is to say people are just going for their work break around that 12 and 13, and definitely they might feel like ordering pizza. And after that, once the breaks are done, and you can see it from 2 p.m. down to like 4 p.m. when everybody is back to work, the orders has gone down again. But it started climbing again at around 5 p.m., which is 17 o'clock. And you can see that it climbed again 17, 18, 19, and then went back down again around 20, which is 8 o'clock. So from 5 p.m. to 7 p.m., we saw like another peak period when people are ordering. So it could be like work is over, people are catching up, or people are going out to meet friends and enjoying different type of pizzas. And now by 20, which is 8 p.m., so everybody is going back to their home or they are in their house relaxing, and definitely the middle of the night, majority of people are already sleeping. So that is why the order has gone down. So you can see the cycle when it is peak and when it is down. So this is actually a very good time series analysis of the business, what is happening. So this has answered the question, what does pizza orders look like by hour of the day? So let's move to the next question, the sixth question. So this is asking us, what is the average number of pizzas order quantity received per day? So now we are trying to look at the quantity of orders that we are receiving. So it's not just about the order, it's the quantity that we are receiving. And what is the average of those quantity that we are receiving per day? So questions like this help us to plan the amount of dough to be produced so that we can be able to meet demands that we are receiving every day. So now, to do this, we first need to know what is the quantity that we are receiving, and we are going to look at our diagram again to see how we can best answer this question, the table to help us. So looking at this table, we see that we have the orders table, which definitely from this we can only count the number of orders we are receiving by the date, which the date is going to give us the day, and we want to actually see the quantity and not just the order. We are not counting the order. The best thing is to combine this orders details table and the orders table. So let's go back and combine that. So what they are asking us is to get the average quantity received. To even get the average quantity, before we get the average quantity received, let's understand how date is being stored, because date is what is going to give us actually the number of orders that we receive per day. So let's look at this and say select everything from orders and we can see that we have, if you look at the dates that we have now, so we can say this is 1st of January 2015, and we have a lot of 1st of January 2015. We have a lot of 1st of January 2015 and then starting to go to 2nd of January 2015. So definitely the first thing we need to do is to first find the sum of all the quantities. That is, we need to group the dates and get the total quantities that we are receiving in a day before we can then actually find what is our average quantity received per day. I don't know if the explanation is clear. We need to first get the total quantity that we are receiving in a day. From there, we will now be able to get what is the average that we are actually receiving per day. So to do this, we are going to just get the date and combine it with the other details to get the quantity. So what we're going to do is that we are going to make this O, and then we are joining this with other details to get the quantity, which is OD on O dot I order ID equals to OD dot order ID. And now what we're going to do is to say O dot date, and we are going to sum the quantity, which is OD dot quantity as QT. So now we have to group by the date, O dot date, and let's run this to see what we have. So what we want to achieve now is that if we run this, we should have 2015-01, and we should get the entire quantity that we received for that particular 1st of January. And when we look at the 2nd of January, we should get the entire quantity we received for 2nd of January instead of this individual breakdown. And let's run this. So right now we have these, which the dates are not in the order we want. So let me order the dates to be sure. Order dates, order by 1. And this is what I'm explaining right now. So if you look at this now, this is 2015, 1st of January. We have 162 quantity of pizza sold. And if you look at it for 2nd of January, same thing, we have the entire pizza sold for that day, and so on and so forth. Now, once we have it like this, the next thing is to ensure that we can take this and then divide it by the number of days we have in the entire data set. So we have 358 days in the entire data set. So this is a year of sales. We have 358 rows. So what we're going to now do with this is that it's going to be like this quantity divided by this number of days that we have in the entire data set. So that is going to give us the average quantity received or sold per day. So now let's do that. To do this now, we are going to write a subquery again, and this is going to be messy, but I'm going to give us a different way to write this to make it cleaner. So we are going to use this as a new table. So, and just get the average quantity from it. So there's average function in SQL. So what we're going to do is just to bring this down and say select AVG. And because I said this is going to be a new table, so the columns that are available in this table are date and QYT. So definitely I'm just going to say QYT, and this is the table I'm selecting from. So I'm just going to put from here, and let me tab this forward. So the next thing is to give this table an alias. I can just say ordered QT, and let's run this. So now what I'm expecting is to have a single value that's going to tell me the average number of pizza ordered quantity received per day. So let's run this. So there's an error again, and this error is telling us that the order by clause is invalid in views, inline functions, derived tables, subqueries, and common table expression, unless top, offset, or for XML is also specified. So what this error is telling me is that since I'm writing a subquery, then I shouldn't be using order by in the subquery because it is not allowed. So what I'm going to do is just delete the order by, and then let me run this query again. Now I have a single value, which is 138. So I can just call this average AVG quantity . So I'm saying AVG quantity per day. So let's run this again. Now we are using subquery, but this is looking not too clean. But another way we can do is to use CTE. So, and most of the time, what I'm going to do is just copy these because we want to turn this into a CTE. So just copy these and paste it here. So let me say CTE version, and what I'm going to do is to say with CTE always start with, and then the name that we want to call it, let's call it ordered quantity, as our CTE will be this. And then from here now, we can run our query and select this, select AVG quantity from which table? From the CTE that we have just named this. So in order for us to understand it, I can name this, let me name this QT2, so that you understand that this is now coming from QT2. So if I run this, we have to get the same value, and let me say put 2 here. So with CTE, you run everything together and execute. So you see that we have the same thing. And this is actually very clean compared to the one we have at the top because it's easier to read. And you can easily see that this is a temporary table called common table expression. And running this, we are going to get this column, which we called QT. And by selecting the average of that from this, our new CTE, which is ordered QTY2, and now we have our average number of pizzas ordered quantity received per day. So I hope that explanation is clear. So moving to the next question. So this is question number 6, and this is going to be question number 7. So what is the contribution of each pizza category to the total revenue? So this is actually straightforward. In question number 2, I think we have calculated our total revenue. So which is total revenue generated. So out of this total revenue generated, let's run this to understand. So 817,860 pounds out of this total revenue generated. We want to see how each of the pizza category has contributed to this revenue. So which definitely is like breaking down this revenue by the pizza category, if that explanation is clear. So now we have to find a way to do that. And to understand this question very well, what this question is telling us is to find the contribution. And by finding the contribution, you could be saying what is the percentage that each of this category has contributed to this revenue. And to do that, it will be the revenue each category generated divided by the total revenue. That is how we are going to get the percentage each category contributed to the total revenue. So it is going to be the revenue of that category divided by the total revenue. So how do we get the revenue of each of the categories since we know our total revenue? So let's just copy our total revenue because that will come in handy. So copy this. So the next thing is to get the revenue of each category. So let's go back to our diagram. So looking at our diagram, we know that the formula for revenue is price multiplied by quantity. And the category is sitting, the price and quantity are sitting in the orders details table and the pizzas tables. And the category is now sitting in the pizza type. So definitely we need to join these 3 tables together to achieve the revenue of the category. So let's select everything. So we need to first join our orders table, order details table, and call that OD. Join. We are joining the pizzas table and call that P on od.pizza id equals to p.pizzas id, and then we are joining the pizzas details, pizza types on and calling that pt on pt.pizza type id equals to p.pizza type id. Now that we have that, we now start to say we want the category. So from the pizza type table, we can get the category, which is going to be category. And then the revenue is going to be price multiplied by quantity. So we are getting the price from the pizzas table and the quantity from the OD, from the order details table. So it's going to be p dot price multiplied by OD dot quantity, and we need to get the sum of that. So that is how we are going to get the revenue of each category, and then say cart revenue So once we have these, the next thing we can do is that before we run this, let's then group by this category. So let's run this. So we can see the categories and we can see the revenues that are generated by each of this category. So now to answer the contribution of them, which is the percentage that each of these categories has contributed to the revenue, is going to be the revenue of each category divided by the revenue, the total revenue. So this is our total revenue. So what I'm going to do now is that I'm going to put a division sign here and copy this. This is my total revenue. So the next thing is put some brackets to distinguish what we're trying to do. So let's put a bracket here and then put another bracket at this point. So let me put a bracket here and then, so what I'm going to do, let me remove this. This is not needed. So I'm going to remove the alias, remove this. This is not needed. And then same thing for this one, which is not needed. And just tab this. So this is what I want to remove. And then tab this to this side. So now I can remove this around, not to confuse us around. So now that we have this, let's do some space, select. So now that we have this is our categorical revenue divided by the total revenue. So now let's run this and see what we have. So you can see that this is giving us 0.23, 0.25, 0.26, 0.23. So it's looking like what we want. So now we can give it an alias and say percent contribution. And then the next thing is that we can round this up to 2 decimal places. But before we round it up, let's multiply it by 100 so that we get our percentage. Multiply by 100. And then let's round this up to 2 decimal places. And let's see what we have again. So now we can see that this is very neat, and we can see that for our total revenue, chicken contributed, the chicken category contributed 23.96%, while supreme category contributed 25.46%. So in order to make this easier to see which category is contributing the most, we can order these. So order by, just bring this alias to this point and let's run this. So we want to have it in descending order. So you can see that classic is the one contributing the most and veggie is the one contributing the least to our total revenue. So let's delete this. So that is question number 7. We've been able to answer what is the percentage, what is the contribution of each pizza category to the total revenue. So we move to the next question. So the next question is that what is the top 3 pizza types based on revenue for each category? So this is really a very tricky question. So what this is asking us is, what is the top 3 pizza types based on revenue for each pizza category? So now what this is telling us is that if we look at revenue of each category of this pizza, we know there are different types of pizzas there. Which type of pizzas are the top 3 that are contributing to the revenue of that category? Say, for example, if we look at classic, what are the top 3 pizza that are contributing to the most to the revenues that classic is generating? So say, for example, let's understand this better. Let's go to select star from pizza types so that we can see what I'm explaining. So if you look at this now, we have this category, and let me just get the classic category, where category equals classic So let's run this. When we look at classic, we can see the pizza types that are in the category of classic. We have 8 pizza types. We have the big meat, we have the classic D deluxe, we have the Hawaiian, we have the Italian capicolo, we have the Napolitana, and we have all these. We have these 8 pizzas that are contributing, that are in the category of classic. So which of these are the top 3 contributing the most to the revenue that classic is generating? So that is what they're asking us. So when we look at classic, we want to see the top 3 that are contributing. When we look at chicken, we want to see the top 3 that are contributing. When we look at the other ones, other categories too, we want to see the top 3 that are contributing. So that is what we are trying to look at now. So in order to look at this now, we have to first understand what is the revenue of all the pizza. What is the revenue of all these pizzas? Like each of these pizzas, what are the pizza types? What are the revenues they are generating? In order to get revenue is price multiplied by quantity. So, and we want to get the type, we need to join these 3 tables, the orders table, the pizzas table, and the pizza types table. So let's bring the 3 of them into this place. Just copy this and then just do this. And once we have that, the next thing is that to get revenue is this. We are getting our revenue. And then what we want to do is to then look at the pizza type and the category or the names. So instead of looking at the type, so let's just bring the names into this. So I'm going to do PT category and then PT name. So this is going to give me the pizza type, the pizza category, and the name and the revenue that are generated by these. And then, so let's do group by. So let's run this. So I'm going to call this revenue. And let's run this again. So we now know that the chicken category, there's a pizza named the barbecue chicken pizza, and the revenue for this is £42,768. So now we have this. The next thing is that we then want to get the top 3 for each of this category. We already see the category, the name, and the revenue they are generating. Then the next thing is to see the top 3. That is the people, the name, the pizza that are generating the most, the top 3 pizza that are generating the most. So that means we have to rank these people. So to do that, I'm going to use a window query that's going to look at the category and then rank them and order them based on the revenue from top to bottom. So what I'm going to do now is to write a window query called rank and say over partition by so the partition is the same thing as grouping. So I'm partitioning them, I'm grouping them by the category, by this category, and then I'm order by this revenue. This is our revenue, and that is descending order, and I'm going to call this rank number. So let's run this and see what we have. So now you can see that we have these in a different dimension or in a different shape. We have the chicken category first, and on the chicken category, we can see the ranking from one, the top, the one with the most revenue. The revenue now is £43,434, and followed by the barbecue chicken pizza, followed by the California chicken pizza. So those are the top 3 that I want us to pay attention to. So, and if we move from the chicken to the classic, in the classic also, when we look at the classic, which is starting from here, this is the first one. This is the top pizza generating revenue for us, followed by this, followed by this. And if we move to the supreme, we can see the top one generating the revenue. So right now, what I need now is to be able to extract this for each of this category, the 1 to 3, that is the top 3. So how am I going to do that? The way I'm going to do that is that I'm going to write a filter query. That is, I'm going to filter just 1 to 3 to get me 1 to 3. So now I'm going to do where this rank number, so I can copy this entirely and paste it here and say this is less or equals to 3. That is, I'm selecting anything from 1 to 3. So I'm selecting 1 to 3. So you'll be thinking, why is this not working when we are trying to do a filter? So the reason why it will not work, it is difficult for the where clause to actually take this in and filter that. So the best way for us is to turn this one, everything that we have here now, is to turn it into a CTE, which is common table expression. And this is how we are going to do it. We are just going to say with ranked category as, and then at this point we are going to come here and close it here. So what I usually do to make it readable is just tab this to the right, and now we are going to select everything from this rank category, and we would now have access to this column, which is the rank number column that we have here. So it's like we are turning this entire table into a table called ranked cat. So we are going to say select everything from ranked cat where rank number is less or equals to 3. So once we run everything together, we should have what we want. Now we have, for chicken category, we have the first 3, the top 3, and for classic we have the top 3, and for supreme we have the top 3, and for veggie we have the top 3. So this has answered our question of what is the top 3 pizza types based on revenue for each pizza category. So when we look at revenue of each of the pizza category, we can actually look at the top 3 pizza types that are contributing to that revenue. So that is the question. That is the answer to that question. So to the next question, which is the last question. So this is asking us which postcode area generated the highest pizza order. Let's go to our table to see how we can answer this. And now we are here looking at our tables. We have inspected everything. I don't think there's anything that has to do with postcode or address of customers. So this is not possible to be answered. Not possible. In the real world, you might have questions like these. Your stakeholders will pose questions to you where the data available cannot provide answer. So this is a potential avenue to scale these data sets, to scale our database, to see if we can start collecting information about our customers. And this could be useful in trying to understand delivery pattern, where we should focus in trying to open a branch, because if you are having order in a particular area but it takes longer to deliver to that area, I think it will make sense to say let's have a branch at this area. But right now our database does not have any information about customers' address, which definitely is something we could look at in the future to scale this analysis or improve how the company can generate revenue. So we have answered all these questions, and for portfolio sake, how do we package this? So to package this for portfolio sake, we are going to be saving this into GitHub, and there's another website where we can actually use to then showcase this. So if you package it into GitHub, you can then copy the GitHub link, add it to the website, or add the GitHub link to your LinkedIn profile. So let's go to GitHub. But before we go, we need to save this, our solution, which is very important. So just click on save and find your location and save it. And put it there. So call it solution. So now let's go to GitHub and create the portfolio. So this is my GitHub, and if you are seeing GitHub for the first time, or you don't have an account, all you have to do is create an account and sign in. So once you sign in, you'll be taken to this home page. This is important. This is the home page you'll be taken to, and all you have to do is that click on this new. And what we are trying to do is create a repository. So this video is not teaching us how to actually use GitHub in depth, but I'm just trying to show us how to save our solution. So the first thing is that we are going to call this repository. What is the name of our database? We call the database PizzaPalace. So I'm just going to call this PizzaPalace. And right now, if I want a description, I can give a description. This is a repo of SQL analysis of pizza sales. So the next thing is configuration. Choose visibility, just leave it the way it is. Add readme. So you click on add readme. This is important. We're going to give an overview of what we have done, or an explanation of what is actually happening in this repo. So add license. So we can click on this license. So general public license, and it means anybody can look at this and copy it and reuse the information. So click on create repository. And now this is our repository. So what we need to do in this place is that we have to create we have to create 3 folders. We have to create a folder for the business question we've answered. We create a folder for the data set that we are using or that we have used, and we are going to create a folder for the solution that we have done. The next thing is to rewrite our README. So the next thing is to go back to your file explorer. So going to my file explorer. So I'm navigating to where I have the details of everything I've used for this tutorial. So which is the PizzaPalace. And I already have the data sets in the folder where I want them. So the solution, I've put that in the folder I want that. And the next thing is creating another folder for business question, which I'm going to say business questions, and then drag these questions. These are the questions I answered. Drag these questions into this. So once I have all these three in place, I'm going back to my GitHub again, and then I need to add file into my GitHub. So what I'm going to do is that there are options to create new file or upload file. This is the most important one. So you click on upload file, and once you click on upload file, if you try to choose file, it will be difficult because, like I said, I want us to bring in folder, not individual file. So what we are going to do is that we are going to go back to our file explorer again and just drag it a bit outside like this and drag in the folder itself. So the first one we'll be dragging in is the business question. So that is the first thing we want people to look at. So I'm dragging in business question. And the next one again is going to be the data set. So I'll drag in the data set also. And after that, the next one again is that I will drag in the solution. And once I have all these, I'll just click on commit changes. So once I click on commit changes, you can see now that I have my business questions, data set, and solution. So if I click on this business question and anybody click on this, they can see the questions I'm answering. And go back again, go to data sets, they can see all the data sets I've used for this, and then my solution. Click on solution and it's going to load all the SQL queries that we've just written, and potential clients or potential employers can actually look at this and see that you have an understanding of SQL. You have good grasp of SQL coding. So we're back to our PizzaPalace. So now the last thing we are going to do here is to clean up this README, because anybody stumbling upon this repo doesn't know what is actually happening. So we want to give them an overview. That is the work of README. So we need to re-edit this README. And the README is just to tell us what is actually happening in the whole portfolio or in the whole repo. So what I usually do is that I can write this out myself, but sometimes I feel like it takes time. So what I've done is that I have a prompt that I give to AI and it just generates everything for me nice and clean. So let's go to ChatGPT to do that. So now we are in ChatGPT. So what I do is that I have a prompt already that I've written. So if you check the description of this video, you see the prompt. You get access to the prompt. So it's just basically everything I've done in the project, and it contains the questions that I've answered and the way I wanted to structure it. So if you read part of this, you see I've told it what to do and say it should have 3 headings about project objective, and SQL concept use. And once I launch this, now it's going to generate something clean and nice for me. And you see what it has done. It says you can even further enhance this repo by adding a database schema image, screenshot of your SQL query output, a folder structure such as. So we've done the folder structure already. So what we are going to do is just to copy this. So I'm just going to copy this, go back to my GitHub and edit this. So all I'm going to do is just overwrite everything that's been written and click on paste. So, and then the next thing is to click on commit changes and just click on commit change. And now we have our README. So if we go back to the overview of the repo, so this is the overview. You see now that it has a nice README showing on this place, and anybody stumbling upon this would definitely understand at a glance what is happening in this repo or in this portfolio. So another thing that you can do to make this better is that there's a website called Data Science Portfolio. So you can create a free portfolio here and then add a link. You see this link, the PizzaPalace, this link that we have now, we can then add it to the portfolio that we build on this place. And sometimes what I usually do for AI again is to generate portfolio image. I can just say generate a nice portfolio image to use with this. So, and it's just going to start generating image. So it's not compulsory you do it. If you like, you can do that. So it's going to take some time to generate image. And this is the image it generated for me. So this is actually a very nice one, and I might use it somewhere. I don't know. So now we've come to the end of this portfolio project. So don't forget to like this video, comment, and share. And if you are seeing this for the first time, if you are seeing me on your screen for the first time and you have not subscribed to this channel, please do so that you can see me again. Thank you, and see you next time.